Today here on the bench, the legend, the President Lincoln. Well, this radio came in with a very well-known fault, and well, we could directly start and fix it, but I have been asked recently by a friend of mine, and he asked me, how do you start troubleshooting, and well, what do we need to think about to come or to go in the right direction? And so I thought this might be a good idea to tell a little bit about the basics of troubleshooting. Okay, and therefore the first thing you have to check is if the fault description which you got from the owner of the radio must be verified. So, for instance, this radio here, the Lincoln, came in with the description "no transmit". So the radio does not transmit, and therefore you have to verify if you really have the same finding, or does the radio work in the lab. So that is very important to check, because you know, a fault must not consequently be in the radio. So it could be elsewhere in the setup of the old man. So maybe, you know, your antenna, or the coax cable, or yeah, you know, your SWR meter, which might be in between. So it really could be elsewhere, and therefore, first of all, before you start troubleshooting, you really must verify, is the fault reproducible in your lab. And therefore we start with verifying the fault. And first of all, okay, the radio came in with a description "no transmit possible", so radio does not go into TX. But first of all, I'm gonna check the RX circuit, because I want to see how the radio reacts in the different modes. And therefore I have put the radio on the 10-meter band, 28,500, and it is already hooked to the radio communication tester, and I'm feeding in the signal, and what you can hear is that the radio receives, sorry. And yeah, let's have a look to our communication tester, and what we can see is that really we are feeding in the frequency of 28,501. This is because we are receiving at the radio on the upper sideband, and we are feeding in -73, which represents S9, and you can see that the radio is producing a nice signal to noise ratio. And what we can see as well, we have a clear and clean sign So yeah, we can check the distortion as well. So that is 2.7%, so that is not too bad, because yeah, we are feeding in with half a volt of audio power or audio amplitude, so that is better spoken. And yeah, so we are sure that the radio itself will receive, so that is quite nice. And therefore, yeah, that is the first check. So I'm gonna check the RIT as well, and yeah, that is working as well. So that are some basic checks, nothing special. So switch out the annoying tone. And now we want to check what's going on with transmit. And well, first of all, pressing the PTT, and let's see what happens. First of all, what we can see is that the TX indication on your display comes up, and that is telling a bit, because we know that the processor inside the radio recognize the PTT, and he's recognizing that we want to go into transmit. But on the other hand, even that we can see the transmit indication, even so, we do not see any. So I want to put it on transmitter test. Normally it would change into transmitter test by itself when it gets any RF into the input. But yeah, I've now put it manually into transmitter test, and I'm interested in the power. And yeah, what you can see, so I'm transmitting, so put it into transmit, and have a look here. So there is no reaction, so I'm switching and pushing the PTT, so nothing happens. So that means that it is completely true what the owner has told us, and there is definitely a fault inside the radio. So it is not somewhere else in the setup of the old man's radio check. So there seems to be, from this perspective, there seems to be everything okay, but there is really a problem with the radio. And what we know so far is that, as I already said, the processor inside is recognizing that you know, the radio want to go into transmit, so that is telling a bit. But it won't transmit, and now we have to go for the next step. Well, first of all, you really need to know a bit about basic electronics. I mean, you can't really troubleshoot a radio without any knowledge about electronic basics. So you need to know how all the different components works for itself, which are used in a radio. I mean, I hope that is clear. And you additionally need to know how a radio works in general, because without that knowledge, you are definitely not able to troubleshoot a radio. So first of all, you really need to learn electronics, and this tutorial repair is not is not a tutorial about the basics of electronic, or the basics how a radio is working. So it is more for anybody who has already made his first experience in the area of electronics. So therefore we want to tell a little bit about the process. If you are interested in electronics and you are not so familiar with all the basics of electronics, it might be a good idea to join one of the radio clubs which are available all over the world, because before you are starting your ham radio experience or your ham radio journey, you have to pass a ham radio examination. And well, when you are starting learning for your ham examination, you learn a lot about radios, and as well about basic electronics. And so if you are interested, that might be really a good idea to join one of the radio clubs which are really available all over the world. But okay, let's come back here to our President Lincoln. And well, another important hint is, if you are not working for one of the manufacturer who knows his own radio very well, and he knows normally all the problems which are happening in the field with the radio, then you have to investigate how the radio is working, and how the components are interconnected, and see how the engineers have done the layout. And therefore a real good starting point is always the block diagram, because the block diagram is telling you a lot. So it shows how the circuitry was developed, and how the components are working together. And well, in this special case of our Lincoln here, is that we know it is not transmitting. And one of the basic knowledge within the radio technique is that you have, and let me go a little bit more here into it, is that you have a different supply for transmitter and receiver. So that means all the transmitter circuits all around your radio won't work while the radio is in RX, because that does not make any sense that you have all the transmitter circuits running while you are receiving, because that might produce interference or whatever, and some of the components are used for both for transmitter and receive, and therefore you have RX and TX switch, and you see for RX you have 8 volt, and for TX you have 8 volt, and then you see here, I need to go zoom a little bit out. You see this here is your power supply, so that is your maybe your battery in your car. So this is the power input of 13.8 volt, and then there is a basic regulator, and there are some circuits which are always supplied with power. So that is for instance your microprocessor, because yeah, the microprocessor needs to know in what, or better said, you know, the microprocessor is a guy who is doing the complete switching inside the radio, and that is always needed. But then you have your RX and TX switch, and when you push your PTT in your microphone, this guy, this is this switch here, then you know, you activate your TX. So that is what you want to do, and the processor, who is always supplied with this track here, is telling to the rest of the circuit, hey, now we want to go into transmit, and is switching the 8 volt to the transmitter circuits. And well, you know, we have seen that the processor is ready for transmit, because we have the little TX information in the display. But what we do not have, we do not recognize any output power. So the first question obviously is, does, you know, really the TX switch go into transmit? Are the 8 volt available when I have pushed the PTT, or is this 8 volt missing? And you know, the good thing is that now with the diagram we know that the Q125 is the guy for transmitter. So this Q, that is most likely a transistor, is switching the 8 volt through, and on RX side we know that is another transistor which is supplying the RX components. And then we have a switching transistor, which is a Q136, and yeah, you know, that must be the one who needs to switch this Q125 when PTT is pushed. So now we know the basic of this TX and RX circuit, and now we must look much more into detail, and therefore we use the real schematic. Ooh, and this is a schematic, and what you easily see, this all can really confuse you. And yeah, believe me, sometimes that is exactly what the manufacturers are doing. They want to confuse you for, I don't know, for any reason, and you always have to expect that it is a little bit funny what you find on schematics, so that is sometimes not very easy. But anyway, what we want to look for is our RX TX switch, and yeah, we know that we have to look for Q127 and Q125, and let me zoom in a little bit here, and yeah, what we find here, first of all, here on the right hand side, this is here our input to the radio. So this comes from the battery, so our 13.8 volt, and well, this here is our basic voltage regulator, which we have recognized as a permanent power supply. So let's have a look once again. So this guy, the regulator, directly after the power supply is the regulator, which is supplying permanently the radio or the respective circuits with power, so it is always available. And then we have our switching, and well, that this once again, where is it? That this 8 volt must be available is very obvious, because you know our receiver is working, and when our receiver is working, we know that the regulator voltage must be available, and this switch here must work as well, and therefore it is essential to do some tests directly at the beginning of the troubleshooting. And yeah, okay, so this here is the regulator, and this guy here, is it possible to get it into focus? This guy is our Q127, so that is marked down here, Q127. So this here is our receive switching transistor, and this here is our Q125. And from the block diagram, we know that this guy here is our transmitter switch, and that means that this transistor is supplying all the transmitter circuits. And when we zoom out a little bit and we are following the line down here, we can see, so this here is all the transmitter circuits, and you can easily see that this transistor is supplying all the transmitter circuits. And therefore what we really need to do is, do we have, first of all, our 8 volt available at the emitter of the Q125, and when we push the PTT, is then the supply voltage of about 8 volt available at the collector, because if the voltage is available here at the collector, then this transistor is working and is supplying the TX circuits. But how can it work? Well, therefore, we have seen here in the block diagram that we have a TX switch, or, well, the guy who is responsible that the TX switch is going to work. And the Q136 is this guy here. And well, if you look a little bit into it, you simply recognize that, you know, the TX transistor itself is a PNP transistor, and that means a PNP transistor needs a low at the input to switch through, and therefore we really need here at this point we need ground that this transistor will work. And well, if I'm looking a bit more into detail what we have here, we see that the Q136 is connected with its emitter to ground. And if and as this is an NPN transistor, that means that if we get a positive voltage at the base of this transistor, then it will switch, and that means that ground will automatically available here at the base. And that means that you know, if ground is available, that automatically means that this transistor can switch through, and the voltage is then available for the TX circuits. So that means, as we now know how this RX TX switch must work, we need to find where you know, the switching voltage is coming from, because, you know, when we push the PTT, we know by now that we need a positive voltage here at the base. So therefore, next step is we need to find you know, the component who can supply the positive voltage to the base of this transistor. So therefore, we go back to our block diagram, and we want to check, is there an information where our Q136 will get the positive voltage from, but as you can see, so there is really no additional information, and therefore there is no other way than to go back into our real circuit and find where this transistor will get its positive voltage of about I don't know 4 5 volt whatever, where it comes from. Well, and now it really starts to become a little bit tricky, and you need to find the way through your diagram, and so I may show you one idea how you could manage it. Well, if I have something like this, I take a color pencil and simply draw our trace, and you may see that it is still a little bit tricky, because you have so many lines all side by side, and therefore you must do it really carefully. But okay, so let's do this here, and okay. So that leads me to a component which looks like an amplifier. So, well, that is the international sign for an amplifier. And we have additional to that, there is a Zener diode in between, and well, so we do only have an information that it is Q, I don't know. So that is another another problem very often, that the copies you might get are difficult to read, and that is what we have here as well. So we not sure what it is, but anyway, even if we do not know the voltage of this Zener diode, we know that we must have a DC voltage available at pin 8 of this IC, and then it should be, this voltage should be high enough to break through this Zener diode, and will then supply at least a positive voltage to our switching transistor down here. So, okay, we know this is a point where we should get a DC voltage, and we know this guy here is the IC 104. And so what the hell is this 104 doing? And therefore, back into our block diagram, and as you can easily see, the IC 104 is the mic amplifier. So what has the mic amplifier to do with our switching voltage, which must be available to switch our Q 136. I mean, the mic amplifier is responsible for amplifying our microphone voltage. But yeah, what does it do in conjunction with our switching voltage? So this is now really a question which can't be directly be answered. So, well, what might be the next? Well, we know that the IC104 is an NJM 4558, and therefore to understand what this guy is doing, the easiest way is to look for a datasheet of the NJM 4558 to understand what this guy is, because, well, this drawing basically will tell us that it is a kind of amplifier. But, well, anyhow, when we see in the block diagram, this is the microphone amplifier. What does the microphone amplifier, what has it to do with our DC voltage, what we need to switch between RX and TX? Okay, so I have looked out for the datasheet of the NJM 4558, and yeah, you can see that is what we were looking for. And well, let's have a look about what are we talking here, and what you simply can see. And now it becomes much clearer. So what we have here in the radio is a double pack of a normal operational amplifier. So it is simply a dual op amp in one pack. So okay, so that makes sense, because we know we can use one of these op amps for amplifying our microphone signal, and we could use the second one for you know, switching voltage, because you know, if we do the right circuitry around the inputs of an op amp, it is easy to switch between high and low at the output. And what we can see here, one output is 7 and the other output is 1, and well, the supply voltage for our op amp is 8, which is here, and 4 is minus. Okay, so now let's check again what we have in our circuit. Okay, so here back into our circuit. So yeah, so the type number is right, and now what have we seen in the data sheet, that point 7 and not point, pin 7 and pin 1 is the output of the amplifier, and so what is that? So that is again a little bit confusing. So our voltage which we need for switching should be available at pin 8, but as we have seen in here, yeah, pin 8 is the pin for power supply of our double pack op amp. You see, pin 8 is the input, the supply voltage for this operational amplifier. So we have another challenge. So we need at pin 8 our switching voltage. So when the transmitter is keyed by the PTT, we need here a switching voltage. But well, once again, check here the type, and it is NJM4558, and what we have here is exactly the same indication, and well, we can find here the different housings which are available, and what is that? We can see, well, we have a V, we have a L, and we have a E, and a M, and a D. So these are the different housing types. And so what does we have here in the circuit? And we can see, have a look, this is a S-type. Oh, so that must be maybe different. So I know that it is a pack like this here, but you know, this can't be the right one, and on this on this data sheet there is not really the type available which we are looking for, and therefore and you know, that is something you really must have in mind. There is another data sheet, and have a look. It is exactly, so can I put both somehow together? Can you now? Yeah, you can read now both. So both have the same part number, right? But on the second one, there you suddenly find an S-type. You can see it right here. Now we have an S-type, and when we go now much more here into the detail, you suddenly see, let me go a bit closer, now you suddenly see, now we have pin 8, which is the output of the op amp, and pin 9 is now the supply voltage, and now it makes sense. So we know here we can definitely get our switching voltage, which we need to switch between transmitter and receiver. Now it makes sense, and now you see how important it is to see exactly what is mentioned in the schematic, because this little S really makes a difference. And now we know pin 8 is you know, the output. But anyway, what you can see as well is, okay, this is really a sign, and it is the international sign for an amplifier. But what I really want to show you is that, well, they could have put this both amplifiers, operational amplifiers, they could have put both into this drawing. Then it would have made much more sense right from the beginning. But they did it this way. The question is, why? I mean, you know, this is hopeless. If you do not have a data sheet, you are lost. And, you know, that is something when I said, is it something that the manufacturers want to lead you onto the wrong track, or what is the reason that they are confusing us by drawing like this? I really don't know. I mean, it would have been much easier for any service engineer to really understand how it works. But anyway, I hope it is clear what are really the basics are. And now we know a little bit more about how you know, the circuit is working itself. And now, after that, now we can start do our first measurements. So now we can probe the circuit. And yeah, what I really want to repeat once again, you need to understand how the circuit works. You know how you need to know how basically a radio is working, because without knowing that you have RX TX switch, without knowing that, you never have an idea where you should start searching for the fault. And then you need to check the circuit, you need to find the traces, and you need to understand how it all works together. And then, now we are at the point where we can start do our first measurements. Well, you know, and after we already are still shocked by the confusing schematic and well, all what we have seen until now, we are in problems again. So when we look a little bit more into the radio, we simply recognized that we have a lot of components down here, and how can we find now the components we are looking for? And I mean, we know here from our block diagram, we need to find the Q127, we need to find the Q125, and of course the Q136. And well, so that is really a pain, because you have so many components, and So that is hopeless. So how will you find something in here? And the next issue is, let me check if we are able to get it into focus. Let me see if we find a guy where we really can demonstrate it. I guess I have to make it like this. Yeah, this is a bit complicated, but anyway, yeah, focus. So let's have a look to this resistors. So this is funny as well. So there is no information on the PCB what the resistors are cold. I mean, you can see that the diodes do have an indication, and we can see, okay, the transistors do have an indication, but all the resistors are without any information. But anyhow, even if there is an information available, like this D175 or maybe this Q128, okay, I mean, this is basically very nice, but you know, it really doesn't help to find the components, because it is really a problem to find now here on the board our requested transistors. Well, now we need the PCB board plan, and this is this main PCB layout, and yeah, with the PCB layout, it is much easier to find the components you are looking for. And let me zoom in a little bit, and what we can see here. So here is our Q136, and here's the Q127, and here is Q125. Yeah, and we know the Q125 is at least our transmitter supply transistor. So now we know where these components are on the board, and therefore now let's go back into the circuit itself, and yeah, okay, somewhere here it should be, and I don't know, I guess I have to do it like this, and there you can find the transistors we are looking for. So you see, this is the Q127, and this here is the Q125, and this guy, where is it? A little bit complicated through the lens here, and this here is the Q136, Great, so now we know where these transistors are on the board. But we are in trouble again. We are really in trouble again. I mean, okay, we know now where the transistors are, but there is really nothing mentioned. Where are the base, where is the collector, where is the emitter, and yeah, if we don't know where the pins are where we want to probe, so that is again a pain. So how can we do that? Okay, first of all, let's check it for the Q125, and the Q125 is a 2SB5250, and the only way again is to look out for the data sheet, that we know where are the pins at the components, because what we need first is to see if our 8 volt is available at the collector, then at the emitter, sorry, then we are gonna probe the collector, and we press the PTT, and when we press the PTT we should have here as well our supply voltage, and if it is not there, then we're gonna check if there is a voltage change while we press the PTT at the base, and yeah, then we know a bit more about what is going on here. Okay, so first of all, let's check what a 2SB5250 is in the datasheet. Well, Google is telling us that 2SB5250 is not available. So, what does that mean? Yeah, that simply means that my copy is as bad as it could be. So that is not 5250. So that is a different type, and that is a challenge as well. As I already said before, sometimes your data sheets are, or your schematics are so bad as my copy is as well, so you do not really can figure out what it is. But under supplemental data information, I found this. So it is 2SB525C, so it is not an O, it is a C, and that's the reason why Google cannot find it. But have a look with this information. We now clearly see where the base, the collector, and the emitter is, and that means we are now able to do our first probing after all this preparation. So that is really the basic of troubleshooting. You really need to gather all the informations that you are really able to do the probings to be able to find the problem. Okay, so and now Q125 is down here. So it is this guy here. And yeah, for the first time our meter is on, so we can't start probing. And from this diagram we know now where we can find our emitter, because once again we want to check if at the emitter if there is our 8.0, yeah, 8 volt, and we want to see what happens on collector when we push the PTT. Okay, so first time, here we go, and here is our probe, and down there, you can't see it, that is really difficult through the lens. And now, okay, so now I'm probing the emitter, and have a look. So we have our 8 volt available at the PTT, so at the PTT, at the emitter, sorry. And now let's check the collector, which is in the middle, and now I'm probing the pin in the middle, and you can see there is nothing, so that is right up to now. And at the base, so now I'm probing the base, and yeah, so that is good as well, because we have 7.5 positive 7.5 volt at the base, and that means this transistor is completely closed and can't supply any voltage to the TX circuit. So that is really good information. So, well, from that information I would say that this transistor is working, and we do not have a problem. And now we want to check what happens when we press the PTT. Okay, once again, I'm now probing the collector, and now I'm gonna press PTT, and as you can see, yeah, that is almost nothing. So that is not a supply voltage. I mean, there is, yeah, that is really nothing, because you know, this is 10 millivolt, so that is 10 millivolt, and when I press PTT, then we have 20 millivolt, so that is really nothing. So, you know, that is not what we are looking for. But let me now probe the yeah, so that is the base again. And what happens when I press now the PTT? Yeah, you see nothing happens. So that means I guess that there is something wrong with the voltage, which should be available at your switching transistor down here. So let us directly check the base of this guy here. Okay, it is this tranny here, and what we know from our supplemental datas, we know that where the base is, and that is what we're gonna probe right now. Okay, so I'm probing the base right now. So this is in receive, and as we have discussed before. When I'm pressing the PTT, we need, I don't know, 4 or 5 volt, whatever, to let the transistor switch. And now I press the PTT, and you see nothing happens at the base. So that means that yeah, the radio can't go into transmit because I have no reaction down here. So okay, so that is telling a lot. So next will be that we have to probe pin 8 of our IC, what is it, 104. I hope I was able to read it correctly. Yes, IC 104, and therefore we must check where it is here on the board, and what we can see, it must be here down at the end of the board. So that means it must be down here under all the wires. And have a look. So there we have our IC. And yeah, when I zoom it in a little bit, you can see here at the left hand side all the wires again. Yay. So okay, down here, no, the focus is not very good. So is it better right now? It's not perfect, sorry for that. But that is our diode, and at this diode we have at the cathode we have directly the output of the op amp, and on the anode that should be the voltage which goes directly to our Q136. So let's probe what is gonna happening down there. So we need to probe yeah, here and there when I switch into TX, and that is what I'm gonna do. But yeah, first of all, let us bring our meter here back into the picture, and I'm going down now to pin 8 of our op amp, and yeah, I am now pushing the button, and what you see is nothing happens. So yeah, we do not get the voltage right out of, you know, right out of the op amp. And so what to do? That is now the question, and therefore I will take our schematic once again and have a look what we have. Well, what we know from our data sheet, we have to check next if the dual package of this op amp will be supplied with DC, that it can work. So the supply voltage for this op amp. Yeah, from our data sheet we know that pin 1 is the supply voltage for our dual package, and yeah, that is what we gonna check next. On the schematic we can clearly see that we have here the power supply for our dual pack. So now let's check if if the power supply is available at pin 1. Well, again, a little bit difficult to show, but down there we have pin 1. So let me probe pin 1. I know it is now a little bit difficult, really difficult to show, but I'm at pin 1 of our dual pack, and what you see is that we do not have any supply voltage at well, this op amp. So so without any supply voltage, it is clear that yeah, the op amp is not able to deliver a voltage at pin 8, which is the output of one of the op amps. So yeah, that is clear. So we only have 60 whatever millivolt, so that is almost nothing. So something is wrong, and well, we do not know why. So yeah, we must try to understand where this supply voltage have to come from. Well, and we have to do our game with the color again to find the right traces, and this is pin 1, so we know at pin 1 we have our supply voltage, so it goes over here, and well, what we can find here is that you know, it has so there is the trace, and it goes down here until this resistor. Oh, that is very interesting, because well, so we can do a next check, because we have here a resistor of 100 ohm, and well, if we do not have any supply voltage at the input pin of our op amp, it is now interesting to know what gonna happening at this resistor, because if this resistor is working, so that means if it is not burned out, and we have at one side of the resistor our supply voltage, and at the other side we do not have any supply voltage, we could conclude that there must be a shortage somewhere here in this area. So that could be the op amp itself, so maybe it is shorted so that it has been toasted, I don't know. Or there is something in the periphery around this op amp which is faulty. So yeah, let's see what where this resistor is, and yeah, what is it called? Can we read it? I don't know. What is it? So that seems to be again, it is a bad copy where you have to fight with, but for me, now focus is gone, but for me it looks like that it is R40. So let's find our R40 here on our PCB layout. So this here is our IC, what we already know, and at pin 1 we know there should be our supply voltage, and yeah, have a look, there we have our R40. So let's check what is gonna happening at R40. Now we know where it is. We need to find it down here in the circuit. Yeah, here is our IC. Okay, and so that means down there this resistor down there must be our R40. So let's check what we can find at the R40. So meter is again in place so that you can see the display. And I will probe first the leg which goes to the IC. So I go now down to the leg and I'm at the leg. I go away once again, so you see, so this is 0, and now I go to the pin which is connected to pin 1 of the IC, and you see we have 75 millivolt. So that is nothing. So that is what we have already measured at the IC. So no supply voltage. So let's go to the other leg of this resistor, and I'm now at the other side, and have a look. Here we have our 8 volt supply voltage. On one side of the resistor it is available, and on the other side it is not. So so that could mean that the resistor itself is faulty, so that it is burned off, for example. So what we should do is check the resistor. So therefore I simply disconnect our radio from the supply voltage, and yeah, let us go back to the meter. I switch it to ohm, and I take the second probe, and let's take the second probe. I go now down to the resistor once again, and let's check. I mean, it is in circuit, and it is not completely clear what we get displayed, but well, it is showing 5 ohm, so it will be in parallel with another component, but anyhow it seems that it is not dead. Even we should read 100 ohm, but anyway, I would say this resistor is working, so there is something in parallel that we measure this little resistance. Okay, back to the schematic. I mean, we know now that this on this resistor we have at this side our supply voltage. At the other side there is almost nothing. So what does it mean? Maybe we have a shortage in our dual pack, or what it is much more likely that some have a more detailed look what we can see here. So we have here 2 electrolytic capacitors, and well, you know, after a period of time, electrolytic capacitors are really jeopardized to go faulty because they are drying out, and whatever happening inside of these capacities. So before we gonna pull out this double dual pack op amp, we should first of all check the capacities around the integrated circle, because most likely we may have a problem with the capacities, even that this or not even, or just because this radio is a couple of years old, and it really could be it really could be happened that this capacities died. So this will be the first of our next what we are doing next. And well, if we go here back into the circuit, we see that okay, once again the that is a bit too far. So this guy down here is a C75. It is a 470 microfarad capacity condenser, and this is a, what is it, C60. Okay, let's have a look on our PCB layout. Okay, the 75 is this guy, so it is right beneath our R40, the C75, and the C60 is down here. So this both capacities should be checked first before we really go and pull out this IC. The next challenge. So I've flipped the board over so that we have access to the solder side, but I cannot. Yeah, you remember. So what we are looking for is in this down area, and well, on the other side we have here the processor board. So down here we have the processor. So I cannot really go down to the PCB where we have to go to, and therefore I have first to put this board away, because otherwise I have no chance to get to this electrolytic capacities. Okay, down here we have our capacitor, which was suspect to us, and well, I'm gonna switch my ohm meter to beep, and let us check this point. Oh, you hear that? So this is a capacity, and as we all know, a capacity should not give us a low resistance, so it should block you know, all the DC. So therefore I guess that this capacity is shorted out. So okay, let's solder it out, and then we are clear what has happened to this guy. So okay, let's take it out. So I've unsoldered it, and here it is. So now let's check what we can find. Okay, here we have our friend, and now let's check him. Oops. So that is what we do not want. Okay, let's check him, and yeah. Okay, so here we have our problem. This electrolytic capacity is shorted out, and that is the reason why the dual pack does not get any supply voltage, because you know, with a shorted capacitor it will not work. It is a 220 microfarad 10 volt, so we will replace this guy, but first of all let us check what is with the second capacitor, which is also very close to the dual pack op amp. Well, the second capacity is out as well, and it is 220 microfarad as well. The same capacitor as our shorted out one, and this one is not shorted out, but you know, this guy has lost capacity, so it is not working really correct. So you see, it should have 220 microfarad, and it shows only 100, let me say 130. So that means this guy is dying as well. So let us replace both, and then we will see what the radio does. Okay, one is already in, so let's put in the second one. Plus to this side, minus is there, and yeah, so here we have already a little problem with the place, but that is good. So now the both new electrolytic capacitors are in. So let me solder it back to the PCB, and then we can check if the radio will transmit again or not. Okay, radio is assembled back. The new capacitors are in, and yeah, we can hear that it is receiving. So we switch the tone off. I mean, that is what we know, but we are interested. Does this radio now transmit again? And let's have a look onto our watt meter when I switch it to transmit. And have a look. So it is transmitting 21 watt output. And you see, it is also modulating. It is yeah, 20.7 watt output out of this radio. So TX, there's a TX sign, and you see there we have our output power. So radio is back in service. That is what we wanted to get. Well, I hope that this little troubleshooting basic tutorial gives you a bit of an overview how you can prepare your troubleshooting. And well, if you think that this was interesting to you, so please a big thumbs up, because we are at the end of our video. You see our transmitter is working again. So the fault was the shorted out capacitor, which was down here. And yeah, thank you very much, and catch you next time.